Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to Product Development Series with the Shredder. So basically we determined in the last video that this was a pretty steep gear here, and also we did the math that it didn't matter if we had an intermediary gear or a number of intermediary gears. It only mattered between the output gear, or I guess you'd say the input gear, and the output gear size. So it didn't matter how many of these guys you put in between, you're still going to get the ratio between the input gear and the output gear. So we then proceeded to look through some of the high torque gearboxes and see if we could find another way or another motor or so to step this guy down so that it will work how we want to. So again, we determined that we needed 350 foot-pounds for about 350 newton meters for 260 foot-pounds. So we're going to go through here and see if we can find something like that. I still can't believe. Still can't believe that I can't find just something off of the shelf here. Interesting. And, you know, I'd prefer something like this. A little bit steep for my taste there. And the other thing is that these planetary gear sets, they have a certain efficiency. Again, we don't need something high precision here. We just need something slop with. It could have a whole bunch of slop. It doesn't matter. It's only turning one direction. Well, you know, it could turn back and forth, but it doesn't need to. Yeah, it doesn't need to be precise on its back and forth motion. There's a DC motor. 6 Newton meter. Way too low. So a two-stage reducer of these is going to definitely increase the price. Oops. Shoot, how are we gonna do this? There's gotta be something. Okay, so rated torque at 30. Speed RPM 30. 30 to 27, sure. Kilogram per centimeter. Minuscule. It is 31. Man. $2,700 RPM. 2840. Okay, so I mean, the biggest I could step it down was what? Four and an eighth. So 600 divided by 4.125. 145. 290. Okay. But I'm going to increase the torque 4 times. I mean, that's good. Still too high. The question is really, what else can I do as far as a planetary gear set? Because basically it just changes between different stages, and you have the inside drive, the next one, let's say, next one, blah, blah, blah. Right? Something not easy to make. Something not easy to make. I mean, the only other thing I could think of is that because it is a tiger, because it is a DC motor, I can lower the speed, but it feels like on this one it uses the controller to change the throttle. I mean, it loses a lot of power. Because when you speed it up, you can't hold it. So we need a way that we could vary the RPM. And because again, this is still a DC motor, so you still have the torque curve. The lower you are on the end of things, the more torque that you have, right? And again, we're kind of operating at middle speed anyway, so we're operating at what, 60%? If we didn't have a gearbox, and plus the amount that they're going to use it, they're not really going to see any savings as far as electricity. This thing's 1,000 watts. Even if it stays on for an hour, which I highly doubt it is. So let's say, even if it was at 600 RPM divided by 2, that's 300 divided by 4.125. It's equal to 72. Because again, really, we don't need max power. We want maximum torque. So we could even drop that down further, and we could just gear it the best we can. I mean, we're gonna leave some efficiency on the table, but obviously, it's gonna cost us dearly to do that. So, looks like we're just gonna have to limit speed on this one and kind of just live with it, I guess. So we're gonna have intermediary gear here, and we'll probably just drop it this amount. Probably won't use a gear here. We'll just use this gear and drop it to 2.76, or basically this between this and this. So this is 2.5 pretty much. 2.5 RPM. 2.5 to 1. So drop it 2.5 times and have an intermediary gear here with a bearing. So let's see, how big of a bearing can we put in here? You can only put in smaller than a 3/4 inch bearing. So, and what is that? Millimeters to inches. Millimeters to inch. And we are looking for, say 0.75. So that's about 19 millimeters. So 19 millimeter OD bearing. Hey, look at that. Oh, but that wasn't, so it's, what was the exact dimensions of this guy? Oops. And again, and actually this piece could basically be put on this thing here. Shh. Because really it just needs a small hole drilled here. It needs a hole drilled here, so this thing could actually end up here, and then we put a you know, like a housing around it type stuff. So what's the standard 608 ZZ ball bearing? What are those dimensions? 8 by 22 millimeters. So let's see. Yeah. Okay, and then it's a 8 millimeter inner. Okay. So basically what we're going to do is we're going to put a bearing not on this surface, but sitting on top to get it kind of up to this point. Stop. I'm going to open up my door, so let my cat out here. She's fucking. So this is 0.322, and the bearing is 7 millimeters tall. So 7 millimeters is about pretty close. 276. Maybe put a shim underneath there or something. Well, technically we could put a washer and step it up another 1/8 inch. Yeah, pretty close to an 1/8 of an inch. Maybe even a little more, so that's fine. So let's say that we did that. So let's go back here. Let's put it a 608 ZZ ball bearing. What was over here in this one? Actually, this was the height that I needed. Oh, so that's small. We'll back this off though. But that's the idea, is that the gear goes around this piece here, because this is basically driving it. And there's basically some space there. There's some space there, so this shouldn't be a problem. We could just adjust how tall this is, because there is some room here, so this could be like, we kind of like slot this out, it doesn't really matter. And this could come up to a certain length, and then we use that to kind of get it up to the right height. So we could just put the 608ZZ ball bearing in there, no problem. So let's go ahead and do that. So this is 22 millimeters. Oops. Okay. Okay. What? Okay, so now basically what we have is now we have to do, let's see if we can mess around with that script really quick. It's 21 minutes. And basically, we're going to go in Tools. Pitch diameter. Pitch diameter is 2.76. Okay, let's start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. 10 teeth. 2.76. 10 teeth. 2.76. Doesn't really matter. Sure. .76. Okay. There it is. Okay, so this is intermediary gear. Okay, so we got ball bearing 2.76. Let's see what it looks like. Oh. Oops. I see. So it's a little big. Oh, but they mesh. It's weird. Oh no, that's a circle. Why can't I see this though? And where is this located? Oh, it's located a little bit up the teeth. Oops. So, yeah, a little bit up the teeth. Maybe scaled slightly, it looks like. Ooh, yeah, it's way too long. Okay. Why can't I see that though? Okay. Interesting. Okay, so this is the center hole, I believe. Oh, there it is. So that's the center hole, I think. Yeah. And then this is the contact. 1.896. No, that can't be right though. Oh, here it is. 2.5. Strange. Oh, wait a second. Is it 10 teeth or 9 teeth? Ten teeth. Okay. 10 teeth. Okay, did I put 9 teeth on that one? Yeah, 10 teeth. This is 10 teeth, but it's bigger in diameter. So, messes with the teeth a little bit. Interesting. I mean, it needs back up a little bit, but not much. Okay, so I'm gonna do some more thinking about this. Might have to make this guy smaller. I mean, this guy doesn't really matter. Again, it's the difference between this other guy and this guy. So this guy could be quite a bit smaller. It doesn't really matter. So in the next footage, what we're going to do is we're going to finish this motor assessment up. If I think of anything in the meantime, for the motor we'll do that, but it looks like we're just going to have to settle with changing speed to drop torque down, and then run it at 30% efficiency or something like that. The motor at 30% efficiency out versus 80, so we're gonna lose a little bit over 30. What is it? We're gonna lose like 50% more power than we probably should need to, but hey, that's okay. So basically, if that was the case, what we're going to be running is we're going to be running 30 times 4.125, so we're going to be running at 120, right? Divided by 600, so we're at about 20% max speed. So technically we're going to have very, very high torque, very low RPM. Yeah. Alright, so this has been Steven from Legit Tech Tutorials and the Green Engineers. Thank you so much for watching, and stay tuned. I'm gonna try to make up for these videos over the weekend. Well, tomorrow it's still Friday, so I still have one more day to make up, and then make up a couple more videos over the weekend, and then hopefully move on to next project. Well, actually, yeah. I mean, we have a little bit left to do on the hopper, because basically the design change we pushed out, but I mean, we're basically going to do the same thing over again, so I don't know how much I'm going to get into that. Alright, thank you guys for watching. If you liked this video, please subscribe for more videos like it, and I'll see you guys next one. Take it easy. Peace.